Good morning, 12th class. The topic we are starting today is azeotropes or constant boiling mixture or azeotropic solution. Okay, now in this one, that the word azeotrope, that one is azeotropes or azeotropic mixture, that one is taken from a Greek word meaning boiling without change. Okay, a simple definition, the solution means basically it's a liquid mixture, the solution which boils at constant temperature and can still unchanged in composition are known as azeotropes or azeotropic mixture. Okay, now how is it possible? Okay, generally if the solution without they are boiling, they boils at fixed temperature without any change in composition. Okay, so how is it possible? That also I'll explain to you. Now first of all, this azeotropic solution, generally ideal solution never form azeotropic solution. Ideal वाले कभी नहीं बना सकते, never. Okay, then who will make that azeotrope or azeotropic solution? Okay, actually non-ideal solutions, okay, generally they are able to form azeotropic solution. How? Okay, now in this one, actually when we add solute and solvent, okay, in a fixed ratio, jab bhi when we add solute and solvent in a fixed ratio, then generally they boil at constant temperature. Okay, so that one is basically at that they boil at constant temperature. It depends, maybe, okay, it boils at higher temperature as comparison to the both the temperature of that solute or solvent, or maybe it is low. Now on that basis we have two types of azeotropes. One is minimum boiling azeotrope and another one is maximum boiling azeotrope. Okay, in this one, that minimum boiling azeotrope is also known as low boiling azeotropic solution. Okay, and maximum one, that one is also known as high boiling azeotropic solution. Okay, in this one. Now first, after that, next thing is it's a types of azeotrope. The first one, as I told you, two types we have. Now first one is minimum boiling azeotrope. Okay, now actually why minimum boiling azeotrope? In this one, when we add, now suppose two components, it's a binary solution, we are talking about binary solution. Okay, mixture is formed. Okay, now in this one, now suppose we add, that one is ethanol plus water. You have to add both, it's a mixture. Okay, now okay, ethanol and water, then generally it form azeotropic mixture. Now suppose it forms an azeotropic mixture. Now in this one, that ethanol, you know that boiling point of ethanol, that one is 351.3 Kelvin, or either you can write in terms of degree Celsius also, it's your wish. Now, and water boils at 100 degrees Celsius, converted into Kelvin, that one is 373 Kelvin. Okay, and even their ratios are also fixed. In this one, that ethanol is 95.4% and remaining one is water. When both the one solvent and solvent both combine together, then they form a azeotropic solution whose boiling point is 351.15 Kelvin. Now just check. Here it's a 351.3, here it's a 373 Kelvin, and this, the boiling point of this azeotropic mixture is lower as comparison to the mixture, as comparison to the liquids of mixture. Then just see it's a lower one. That's why this type of azeotrope is known as minimum boiling azeotrope. And this one is showing, you know, we have done that positive and negative deviation for non-ideal solution. So this type of azeotrope shows positive deviation. Why? Okay, because after mixing two liquid, the azeotropic mixture, their boiling point is low. It means particles escape more, or water vapors, or either you can say that vapors are exerted more as comparison to expected. That's why they shows positive deviation from normal one. Okay, now second one we have, that one is maximum boiling azeotrope, or you can say it's a high boiling azeotropic solution. Okay, now in this one, Okay, why it's a high boiling azeotropic solution? Now suppose, okay, we'll mix this one, two components. Okay, one is nitric acid, this one is nitric acid, it's a HNO3. Okay, now nitric acid, its boiling point is 359 Kelvin, plus add with water, again it's a 373 Kelvin. After adding both, okay, they form azeotropic, this one is azeotropic solution. Now check, after mixing both, and in this one that percentage of nitric acid is 68% and another one is, okay, remaining percentage of water. Now in this one when you add both, okay, after that they form a azeotropic solution, okay, which boils at constant temperature without any change in their composition, or either you can say without any change in their concentration. That's why it's a azeotropic solution. Okay, so they boil at which temperature? That one is 393, okay, 0.5 Kelvin. Now just check in this one, okay, that here it's a 359, here it's a 373, but the azeotropic solution formed, okay, their boiling point is high as comparison to both. That's why this type of azeotropic solution is known as maximum boiling azeotrope, because they boil at this temperature only without any change, okay, without any change in their composition or percentage, you can say. Okay, that's why this one is known as maximum boiling azeotrope. Okay, now just see here, boiling point increases, it means tendency of escaping vapor is less as comparison to expected. So this one is showing negative deviation. Okay, this one is showing negative deviation because vapor pressure formed is less. Okay, thank you.